In this section, we are going to learn how heat is transferred by radiation, 輻射. First, let's see how heat is transferred from the sun to the earth. The sun emits electromagnetic wave, 電磁波, such as X-rays, visible light, ultraviolet, and infrared light, 紅外線. These electromagnetic waves can travel in the space, which is vacuum. That means electromagnetic wave can pass through vacuum. After passing through the Earth's atmosphere, 大氣, the atmosphere, this electromagnetic wave will reach the Earth's surface. Among all these electromagnetic waves, infrared 紅外線 is the one that will produce heating effect. We feel hot as we absorb infrared light. The heat transfer by infrared, which is a kind of electromagnetic wave, is called heat transfer by radiation. I repeat, the heat transfer by infrared light, which is a kind of electromagnetic wave, is called heat transfer by radiation. It should be noted that hot objects emit infrared light. The higher the temperature, the greater intensity of infrared light is emitted. Intensity means 度數. Similarly, when an object absorbs infrared radiation, its temperature will rise. The more infrared is absorbed, the higher the temperature would be. Let's see how to perform an experiment to verify 證明 the existence of infrared light. First, let's see the remarks. The first one is that infrared light is invisible to the eyes, 睇唔到嘅. But we can use infrared sensor to detect its existence. Second, infrared light can be named as infrared radiation because it can travel in vacuum. Third, night vision Google 夜視鏡 helps to detect infrared radiation emitted by human beings and other bodies. Therefore, soldiers wearing night vision goggles can help them to fight at night time. Let's go back to the experiment. We have a wave of white light incident to the glass prism. Due to reflection, a spectrum, red and violet, is produced on the other side of the prism. As infrared is at a position just behind red light, we connect the infrared sensor to a data logger. and we put the infrared sensor at a position slightly behind the red light, the data logger will register a reading, which verifies the existence of infrared radiation. Now, let's study an experiment to demonstrate the relation between rate of absorption of radiation with color. The procedures are: we have two identical flasks, one painted black and the other painted silvery. They are filled with water of the same volume and initial temperature. A table lamp is put at a position at equal distance from the flask, and the light bulb is switched on for a few minutes' time. Throughout the experiment, we insert thermometer into the flask to measure the temperature of water. What will be observed? The observation shows that the temperature of the black flask rises at a faster rate than that of the silvery flask. What can be deduced from the experiment? Result: since the lamp is at equal distance from the flask, the lamp emits equal amount of infrared radiation towards the flask. Since the temperature rise of the black flask is higher than that of the silvery flask, it can be deduced that the black flask absorbed more radiation than the silvery flask. The next experiment is to demonstrate the relation between the rate of emission of radiation with color. The procedures are: we have two identical flasks, one painted black and the other painted silvery, are filled with hot water of the same volume and initial temperature. The flasks are then put on the table and thermometers are inserted into the flask to measure the temperature of water. What are the observations? Since the temperature of hot water is higher than the temperature outside, therefore, the hot waters inside both flasks emit radiations to the surrounding. It is found that the temperature of the black flask drops at a faster rate than that of the silvery flask. What can be deduced from the experiment? Since the temperature of the black flask drops faster than that of the silvery flask, that means more radiations are emitted from the black flask. Therefore, we can conclude that objects with black color is a better emitter of radiation than objects with silvery color. From the above two experiments, we can conclude that an object with good emitter of radiation is also the object with good absorber of radiation. Besides colors, let's see other factors that will affect the rate of absorption and rate of emission of radiation. The first factor is temperature. If the temperature of a body T is higher than the temperature outside, then the body will be an emitter of radiation. The higher the temperature of the body, it will emit radiation at a faster rate. However, if the temperature of the body T is smaller than that outside, then the body will be an absorber of radiation. It will absorb radiations from the surrounding. In this case, the lower the temperature of the body, it will absorb radiation at a faster rate. The second factor is surface area. The larger the surface area of a body, the better the absorber or emitter of radiation. The third factor is the texture of the body. If the body is rough, total, and dull surface, dull means 啞色. Rough and dull surface are better absorber and emitter of radiation than smooth, 滑, and shiny surface, 光靈. For 4 kinds of surface, the first one, dull black, second one, shiny black, the third one is a white surface, the last one is a silvery surface of the same surface area. Dull black color surface is the best emitter or absorber of radiation, while silvery surface is the worst emitter or absorber of radiation. Now let's compare heat transfer by conduction, convection, and radiation. Conduction only occurs in solid. Convection can occur in liquid or gas. For radiation, there is no medium need for radiation to propagate, because radiation can pass through vacuum. Infrared is the most common type of radiation you have learned in this chapter. Next, conduction is due to the vibration of molecules. Convection is due to the movement of molecules. And radiation is due to the propagation of infrared radiation. Propagation means travel, 傳遞. The next point is, for conduction, energy is transferred by collision between molecules. For convection, energy is transferred by the movement of particles. For radiation, energy is transferred by electromagnetic wave, which is called infrared, which is one kind of electromagnetic wave. For conduction, energy transmits in a fixed direction from the hot end to the cool end. For convection, energy is transmitted by convection current, usually upward and then downward, the hot liquid or air moving upward and the cold air or liquid moving downward. For radiation, energy is transmitted in all directions. Energy is absorbed by the body in all directions.